Alright folks, welcome to Lid Tips, the ham radio show where we discuss topics or talk about things that are of interest to ham radio operators. In this particular episode, we're going to show how I built a 40-meter dipole using parts I had around the ham shack, as well as some parts I printed off with a 3D printer. If that sounds interesting to you, go ahead, stay tuned, and watch the video. Oh, and if you like the video, click the thumbs up or subscribe. It helps other people like you find the content. Also, there's a link to Patreon below, so now you have the opportunity to support the channel in that way if you'd like. Anyhow, thanks for watching, really appreciate it. Hopefully everybody made it back. I wanted to say that much of this video was inspired by Kevin Laughlin. I believe that's how you say it. My apologies if I said it wrong. He is a YouTuber and a ham, and he has an awesome YouTube channel. Here's a video, and I'll link it below, where he builds a dipole, and he printed out a 3D center point for this. And he was nice enough to share this center point on Thingiverse. And what I did is I went and I downloaded the file from Thingiverse, and I used it for this particular video. Here you can see an example of how he used the file. And then here is what the printout looks like when it's done. So again, big shout out to Kevin. Thank you very much. Let's get on with the video. Oops, I almost forgot. Here's a 3D printer that I use, the Creality Ender 3. I'll include a link to this and a link to the Thingiverse file below. So if you have a printer, you can go ahead and try the same thing. Here's a beginning shot where you can see the dipole center being formed. And then here's a little bit of video where I show the printer in action. Not going to spend too much time here because watching 3D prints is actually kind of boring. And here we go with the finished product. It looks like it turned out pretty good. I'm still learning how to use a 3D printer, so there are some artifacts and some rough edges, but I can trim that up or sand that down. It shouldn't be a problem. That's the BNC connection point. Now here's what I did. I printed two of these, one for a backup, and I drilled out that center hole. I'm not sure why I did it. I thought it would come in helpful when I try to hang this. It's going to be hung in a center V configuration. Well, I should say inverted V configuration. There's going to be an absence of strain relief, but that's because we are going to mount from the center of this. Now here you can see a Balun that I made a while back, and I use this for measuring and sizing. It looks like it's going to fit on this pretty well, so it shouldn't be an issue there. And then finally, I printed out a couple of sets of wire winders. It just seems like a handy way to store my wire and keep it organized. Here you can see some bad artifacts on the back of it, but again, this is going to be fully functional. So for this project, we did use a T140 43 mix Toroid. And then I wrap it with this wire. Let's see if I can get it on camera. And it's just 18 gauge speaker wire from Gear IT. I get a couple hundred feet of it for about $20 off of Amazon. I really like this stuff. I cut about 2 feet of this wire, which is going to be plenty, to do 9 turns on the Toroid. I'm going to use a zip tie to hold the initial wire in place. It makes it a million times easier. Later in the project, we do replace this zip tie when we mount the Balun or the choke to the center point. Let me go ahead and zip this in and clip it off. There we go, nice and tight. Just keep passing the wire through the center of the Toroid, making sure not to twist or overlap with other wraps. Again, I mentioned we're going to do 9 of these. After we get 4, we are going to do a crossover, and we'll see that in a second. Alright, here's the crossover. You just go over to the other side of the Toroid, and then come up through the bottom, and then continue wrapping in the reverse direction. Again, make sure that you're careful not to twist or overlap the wire. And just a quick count to make sure that we have 9 turns. A turn is every time the wire goes through the center of the Toroid. And we're done. So what I'm going to do now is I'm going to zip tie the end of the wire to the Toroid. When putting a zip tie on, we want to make sure that we keep everything as snug and tight as possible. And that looks pretty good, so I'm happy with it. To keep the wires from separating, I cut a few small pieces of heat shrink that I'm going to apply now. And now we're ready to move on to the next step. So far, so good. I wanted to make sure the Balun Choke was at a 1-to-1 ratio. So what I did is I took two 100 ohm resistors and I wired them in parallel. And now I'm testing with a multimeter and I get 50 ohms of resistance. So we're good. Now for the project, we're going to use these BNC connectors. The reason I'm using these BNC connectors is because that's what Kevin used in his video. And that's what the centerpoint 3D print is designed for. They screw apart pretty easily, and you mount them like this, and then you solder your connections directly to the connector. Let's go ahead and get started on that. Okay, we have attached a choke to the 3D print. I used a zip cord at the top, and then we soldered one wire to the post or the pin or the center of the BNC connector, and the other to the shield. Not the prettiest solder job, but it's going to work. I've added two more zip ties for stability, and I removed the original zip ties that we applied. Now we're going to test for continuity to make sure everything still works correctly. And there we have it on the center, and there we have it on the shield. And we're also going to test to make sure that we don't have any shorts. And everything looks good. So here we are taking a look at the U.S. amateur radio bands, and this is a document from the ARRL. I'll link it below so you have access to it. But for this project, we're going to build a 40-meter dipole. And if you take a look up here, 40 meters goes from 7 to 7,300. We're going to target 7.150 as our length. So if you go over here to the Dipole Antenna calculator, I'll link this below, and I've used it in other videos, so it shouldn't be too big of a surprise. I'm going to come over here, and I'm just going to go ahead and I'm going to put in 7150. I'm going to hit calculate. And this gives me my total antenna length, 65 feet, 5.4 inches, or each element will be 32 feet, 0.88 inches. So what we're going to do is we're going to actually cut this short. We're going to cut it at 32 feet, 8 inches, and then I'm going to tack an additional 4 inches on top of that, which would give me a little bit of fold back and some room to play with. So we're going to look at 33 feet. We're going to cut two elements of 33 feet. Okay, now it's time to cut the elements. As mentioned, I'm going to do 34 feet, so fortunately my Stanley power lock's long enough to work. And I use the Gear IT 18 gauge speaker wire. I just love this stuff. Here are the elements wrapped on the winders. And I have a 4-inch fold back that we talked about. I use the zip ties. That makes it easy to make adjustments. I can always heat shrink when I'm done. And then I use an S-beaner as an insulator on the end. They're lightweight and easy to use. Here's the end of the element. Now I just need to apply a connector. Here's what I used for the mounting hardware. These 832 machine screws or bolts. I used some nuts, some regular washers. I used these wing nuts to attach the elements. And I used lock washers to hold the whole thing together. That way I can switch elements out without disrupting the connection posts for the Balun Choke. Here's the order. It just goes washer, lock washer, then a nut, then a lock washer, and then the wing nut. And again, I just unscrew this wing nut and I can switch out my elements. Makes it very easy to put different size. I could do 20 meters, 30 meters, 40, 80, whatever with this. Again, we're going to mount this in an inverted V, so I didn't address stress relief. And I did have to bore the holes out to mount the posts, or the binding posts. And these are the connectors that I use on the binding posts. I removed the plastic and then substituted heat shrink. I find that works a little bit better for me. And I did the same thing on the elements as well. Let's go ahead and get this thing outside, up in the air, and do some readings. We've attached the elements with the wing nuts, and then I attached a coax cable, and I used a zip tie to hold the coax cable against the center point for strain relief, and then I used another zip tie to attach the coax cable to the tip of the mast. Now we're going to raise this thing up in the air about 30 feet. Here we are up about 30 feet, which is not the ideal height for a dipole, for a 40-meter dipole. Also, we're in an inverted V, and so that's going to mess with my readings a little bit. But now it's time to hook up the nano VNA and use some nano VNA saver to see what we got. With my nano VNA calibrated, I'm using nano VNA saver to set sweep settings for the 40-meter band. So I'm just going to go ahead and I'm going to run that sweep now. And as you can see from the results, it's not exactly ideal. The antenna is a little bit long, and then I go over 2:1 SWR at the top end of the band, around 7.2 megahertz. I can go ahead and I can scan through the various data points and see what my actual SWR is at particular frequencies. And I'm just not happy with this. So what I'm going to do is I'm going to go outside, and then I'm going to cut about 2 inches off of each element and see what I get. I do think I have two issues going on. One, my dipole's not high enough. And second, I think the inverted V is a little too tight. I'm actually considering lowering the dipole to spread it out a little bit more. Okay, let's see what happens. After shortening the elements of the antenna, what I have now is I'm below 1.85 pretty much across the entire band, and I'm much happier with this. I didn't lower the dipole, so I still think I have a problem with the V being too tight. We're going to go ahead and try it out. I'm not going to include that on this video. What I wanted to show is how to build the antenna, and then you can do something similar, and then what you can do is that you can tune it yourself. What I'm doing now is I'm opening up the settings from before so you can see the difference. The blue line was before I shortened the antenna. The orange reddish line is after I shortened it. Anyhow, that's going to wrap this video up. Thanks for watching, everybody. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below and I'll do my best to answer. I really appreciate it.